Hey students, I thought I'd make you a quick little video of maybe some highlights of the first exam, if that helps anyone here. Uh, let's look at these three questions, or two and a half questions, starting with this first one. I'll begin by saying, hopefully you'll look at my first video on the solutions. That's kind of the long version. And when you do, you'll see I'm working on this sheet, and I worked this out. And so I would say that if there's any common mistake made here, it really is in number one. Number one is probably most mistake prone compared to the other two. And partly because it's got four parts, but partly there's just some little subtleties in here that hopefully you didn't overlook, but you might have. For example, when it asks for the period of oscillation, which is just the period is 2 pi over omega, that was pretty straightforward. And the omega being the square root of k over m, that was pretty straightforward. But not a surprise, what caught many off guard was missing the value of k. And so let me just point out that, remember, when they're in series, it looks like this. And you can go back to the video here for a longer explanation. But cutting the spring in half means that the two halves have a double their spring constant, and then you hook up two of them, that doubles it again. So the overall spring constant should be 492. And that was probably the common mistake on A, was just to kind of do this once, or even not at all, and have a different period. And I will say, I think, very fair in pointing out that, okay, if you did K wrong, that was, -3, but I didn't take anything off further down. And that's why hardly anybody missed any points in B, because they did the conservation of energy, they did the calculation of velocity. They may have gotten the wrong number because their K was value off back here, but I wasn't going to take off additional points for that. So the common pattern was to miss K, have this correct calculation and get this number wrong, but getting, the credit for that. The only thing missing is the -3 for getting the K wrong. And then there wasn't, obviously not everybody did this B right, but certainly most of everybody did. And then the number may be way off because of the common mistake of missing K. In fact, all four of these, A, B, C, and D, rely on that value of K. So you may have missed it numerically on A through D, but you still might have got a significant amount of partial credit because the logic was right. Now, I will point out in B that it's not the wrong approach, but there were quite a few who took the long way, and they used the equation for the position, which is asked in part C, and then from that got the time, and then used the equation for the velocity of time to answer the question. And there's nothing wrong with that, other than it's longer and harder mathematics, but it'll work. And of course, if you have the wrong value of K, you also get the wrong number for the speed. But I didn't take anything off for that. So you might be in that category, and I'm just going to point out the most common categories are really to have the number here wrong, but only because the K value is wrong. But the logic of A and B are dead on. And if I can say anything about part C, kind of the same thing, that most people did it right. If there was any common mistake, it might be this, that maybe just completely forgot about this phase, so you didn't have the plus or minus pi, or maybe you didn't draw the picture, so you didn't incorporate a negative sign. Not a big deal, but part of the puzzle. I only took off 2 for that, so again, not too many did that, but that if there was any common mistake, it was that. Other than that, it was mostly done right. Now, D did have a common mistake. Sometimes it was just simply plugging in the time value, which was the 5.3 seconds, into the equation of position, and that would give you the position of it, not really how far it traveled. So remember, back in the video, I was talking about it going back and forth. Did I have a drawing of it going back and forth? Yeah, I think I was, during the drawing or the video, I was doing this. And so it would go, 1 amplitude, 2 amplitudes, 3 amplitudes, and 4 amplitudes in one cycle, which is why the first thing I did was to go 4 amplitude at 29 centimeters is one oscillation. And again, just like A, I didn't take any points off if you had done the period wrong back in A, just because the K was wrong. But if you did the K right, it's about 1 second. So that's why it go back and forth 5 times. That's why I took the 29 times 5. And that was done well. Like I said, a lot of people had their numbers wrong because they had done the period wrong. They got a period of like 1.4 was a common wrong number. And therefore, the number of times it went back and forth was not 5 and a little bit. It was more like 3 and a little bit. I think 3.76 was the common wrong number. But your logic was sound, and so you did, 4 amplitudes 3 times, right? And so you had a 3 there. And so you wouldn't lose any additional points for that. But there was a common mistake here where the last part of it, the little fraction, which in this case 0.3 of a second, or if you had the wrong numbers, it would be 0.76 of a second. And you need to take, from, where it is to where it goes. So in other words, you need to use the position equation right here to figure out where it is. And when I did this, I got 2, and that's when we came over here to the picture and said, okay, well, it moved the first amplitude and then a little bit more. And so there's the amplitude and a little bit more, if you kind of remember this from the video solution. And I say that because it is not the same. And so maybe I should say not the same as just saying, well, it's 0.3 of a full cycle, which is 1. Or if you had the wrong numbers, 0.76 of a full cycle of the total distance, which here is 29, and probably 29 was the common number there. But it's not that simple. It's not a linear. It's not proportional. It's not just a fraction. It's not the same distance. And, that's what is meant by a sinusoidal pattern here, whereas if you're just going from one end to the other, the straight line approach would be that. Now that I draw it, I can see that if you do the correct logic and a straight line, they're going to be kind of close there. But that's coincidental. Maybe I should have picked a time where they weren't crossing and quite so close. But that definitely was a common mistake. And maybe both of those, the one that you just put in the position and you didn't really get how far it traveled, or the other one where you just do a percentage, like it's moving in a linear fashion. And so that, rightfully so, is, going to be missed, just like the K value. So that little subtlety, that one and that one, is probably the most missed on the test here. And so it wouldn't surprise me if, a lot of you are missing 3 from this, or missing 3 from this, or missing 2 from this. Hopefully you didn't do all 3 of those. That would be a bummer. But I don't think missing all 3 was that common. It did, I'm sure, happen a couple times there. But that's what I wanted to say about the first problem, if that helps anyone. Now, on the second one, if I say anything, the first half was pretty straightforward. I don't think there was really any common mistake. People realized it was a string, and then and the mass density, and then calculated it. And they did that really well. And then, of course, then they used their Physics 121 mechanics stuff and took the distance and divided it by the speed to get the time. So no common really mistake, although there were a few times where the 30 and the 20 could get confused. Remember, the string is 30 meters long, so when you go to calculate its mass density, you want the whole mass and the whole length, and not the 20 here. But when you go to calculate how much time it took to travel, then the distance is not the full length of the rope. The rope is tied between the two trees, and so the distance would be the 20. So mixing up this 20 and 30 was done a few times, and you know, rightfully so. I can see that. In fact, making the test, I thought, maybe I better make them the same so nobody confuses them. And then I thought, well, if I make them the same, somebody's going to say, how can you take a 20-meter rope and tie it between a tree? You'll need extra length to tie it. So I thought, well, maybe I better make it more realistic. And you always have to have your rope longer than the distance you tie it, because you need to wrap it around and tie it. So I went with the 30 meters. And, of course, I wasn't trying to trick anybody between the 20 and the 30, but could have happened. And so, you know, when I make problems and debate with myself on what to do, I always go back to reality. I said, well, look, you know, I don't want to trick anybody here, but there's the reality. The reality is, if you have a certain distance between the tree of 20 meters, you're going to tie a rope. You got to have a rope longer than that. So I'll let them think through the reality. That's the whole point of this class, physics. You know, take that physical picture and apply it to the world around us. So having them both at 20 would have been probably more problematic than that one. But like I said, most of you caught that right away. There was just a few times that one. Now, the harder one here was definitely B. I would have thought that might have been the hardest one on the exam, but I think actually looking over the K value in A was the most commonly missed. And of course, I'll let you go back to the video solution if you want to kind of remember that, you know, when the speed changes, we got to look at kind of a microscopic distance during a microscopic time, and then add them up. That means integrate it. So you're going to add up all the times, which we can replace time with dx over v, and then we can figure out the density in terms of length. And so I guess I'm probably saying too much because I'm just kind of explaining it. But if you still miss this one, you know, go back and look at that. If there was any common mistake, I would say people didn't really kind of know what to do. They really weren't integrating their power of calculus and their power of mathematics. They weren't really thinking about, you know, the whole idea of calculus where you can get a total by taking an infinite amount of sum. So they did what I called the back of the envelope calculation here. They kind of took the average mu density, and you know, you'll get a number very close to that, as I said in the video, but it's logically not very sound. And in fact, now that I say that out loud, where's my book here? Maybe I'll just point out, because a few of you did this, and I think you were a bit nervous to do it, but hey, that's very acceptable. You said that, hey, we did a problem just like this on the homework. Why can't I just use my homework? And you can. And it probably took you about 30 seconds to do the problem, and I think that's why you were nervous here. But it was number 65, and yes, it is a magenta one, and so yes, it is a hard one here. But it's exactly this, and actually then even has, oops, messing with my cables there. But you get this, and so, you know, a number of you caught on right away and said, well, wait a minute, we did this, and just wrote out this equation and plugged it in and plugged and chugged and got an answer. And yeah, it probably took you 30 seconds. And I think that's why you wrote me a note saying, could it possibly be that easy? Am I doing this right? I'm concerned. And that's fine. You know, kudos to you for recognizing what you had done on the homework and translated really into a test problem. So Yep, nothing wrong with that. And so probably saved you a lot of time to think about the other ones here. So I'll just say kudos. All right, so now the last one, again, probably the easier one, other than it's out of chapter 18. And as some of you admitted to me, it's like, oh no, I didn't have time to do 18, and I'm not really ready for this problem. And so I appreciate your honesty. But it is the interference one, and as I explained, the two different distances should be a little further. We were given D2, and we're asked for D1, and of course then D3 was the sound going to the listener, should be a little longer by a half wavelength. And so, as I put here, D3 minus D2 should be a half wavelength, and we calculated the wavelength. And most of you saw that right away, so good. If there was any common mistake in here, I guess I would say then it might have been in not this side of the equation where you knew it was a half wavelength, but figuring out, what was the extra distance. And some of you put like this, you put D2 minus D1 is a half wavelength. And I didn't know if conceptually you weren't kind of understanding that the sound has to go to the listener, because D1 would be from this speaker to that speaker. That's not getting to the listener. Or maybe your geometry, maybe you forgot about Pythagorean theorem. Not real sure, but this did show up a number of times when it really should be this, D3 minus D2, and then you should be applying Pythagorean's theorem to figure out what D3 is. So D3 minus D2 would be half wavelength and coming out to 2.7. And most of you saw that right away. But like I said, if there was any common mistake, it probably would have been writing this equation for whatever reason. I don't know. It could have been just panicking. You didn't know what else to do, and that looked good, and you did it. It could have been a conceptual idea that you didn't really catch on that the sound goes from the source to the listener, and they combine or interfere at the listener. That's where the listener is recording the sound, and so that's why it has to be a D3. All right. Well, if this helped anyone, great. By the way, it wasn't the end of the world. I took off 3 points for that, so a very common score on this one was 7 out of 10. And kind of makes sense, So a lot of partial credit because you really got the idea, but either your geometry was off or your conceptual understanding was off. And hopefully it was just the geometry, because I usually take off a little more points if it's the physics, but this is just hopefully geometry. All right, take care.